Statistics. Mean. We have the following techniques to evaluate the mean of a given data. Case 1. Simple distribution or individual observation. The mean of a set of number x1, x2, x3 up to xn is denoted by x bar and is defined as given. Case 2. Mean of a discrete, that is, ungrouped frequency distribution. Formula 1. If x1, x2 up to xn are the values of a variable with frequencies f1, f2 up to fn, then x bar is given as shown. Formula 2. Shortcut method. If the frequencies and the values of the variable are quite large numbers, the product fi xi will also be large. Then a shortcut method has been devised as shown, where a is any assumed mean and di is equal to xi minus a.
Formula 3. Sometimes the division of DIS are found to be divisible by a common number h. Say, then we can make the calculation easier by putting ui equal to xi minus a by h, I equal to 1, 2, etc. n. Then x bar equal to a plus h n sigma fi ui I equal to 1 by n sigma fi I equal to 1, where a is the assumed mean. H is the length of the class interval and ui is equal to xi minus a by h.
Case 3. Mean of continuous or grouped frequency distribution. In this case also, the mean is computed by applying any of the formulae given for discrete frequency distribution. The values x1, x2 up to xn are taken as the mid-values or class marks of the various class intervals. If the given frequency distribution is inclusive, then it should first be converted to exclusive distribution. Median. Case 1. For an individual series. Arrange the raw data in ascending or descending order. Then the following rule gives the median. When n, the number of observations, is odd, then median is n plus 1 by second observation. When n, the number of observations, is even, then median is the mean of n by second and n by 2th plus 1th observations. Case 2. For a frequency distribution. When the series is discrete, arrange the data in ascending or descending order of magnitude and then prepare the cumulative frequency table. Let n be the total frequency. Then, if n is odd, median is the value of n by 2th plus 1th item, and if n is even, median is the mean of the values of n by 2th and n by 2th plus 1th items. When the series is continuous. In case of grouped continuous frequency distribution, first of all, we find the median class. That is, the class in which n by 2th item lies is called median class. After finding the median class, we use the following formula for calculating the median, where L is equal to lower limit of the median class, n is equal to number of observations. Cf is equal to cumulative frequency of class preceding the median class. F is equal to frequency of median class. H is equal to class size, assuming class size to be equal. Mode. The value of the variable which occurs most frequently in a distribution is called mode. A series having one mode is called unimodal. Having two modes is called bimodal. Having three modes is called trimodal. And having more than three modes is called multimodal.
Remarks. A data may not have a mode. For example, the data 2, 3, 0, 6, 4, 5 has no mode because no number occurs more number of times than any other number. A data may have more than one mode. For example, The data 3, 6, 1, 4, 6, 8, 7, 4, 9 has two modes 4 and 6 because each of 4 and 5 is repeated twice. Formula: in case of group continuous frequency distribution, first of all we find out the class having maximum frequency, which is known as the model class. Then the following formula gives the mode. Mode equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H, where L equal to lower limit of the model class, H equal to size of the class interval, assuming all class sizes to be equal. F1 equal to frequency of the model class, F0 equal to frequency of the class preceding the model class, F2 equal to frequency of the class succeeding the model class.
Relationship among mean, median and mode. The mode is approximately
Equal to
3 into median minus 2 into mean. Certain points to be noted. First, arithmetic mean is based on all the observations. It is not useful if there are some extreme values in the data. Second, mode is more useful to business persons who may not be interested in the magnitude but only in the most common value or fashionable value. For example, while ordering for shoes of various sizes for resale, a model size will be more appropriate. Third, median is useful when there are open and extreme classes because median is not affected by extreme open values. Representing a cumulative frequency distribution graphically as a cumulative frequency curve or an ogive of the less than type and of the more than type.